Hello everyone, welcome to today's class. So this is what I mean by fractional numbers. So you can see that this number has a decimal point, okay? So we can say if it's in base 10, we can say that this is two decimal places, but we can't say that for base 2. So this is a fractional number, okay? It's a fractional number. Now, what do we do in fractional number? Let me show you something. Remember that whenever you have 1 over 10, that will give you 0.1. Okay? And this 0.1, this can also be written as 10 minus 1. So what do that tell you? That when you have 0.1, this one means minus 1. So when you expand this one here, it's going to give you 0 times 10 raised to power 0. Of course, this one will take 0. Then this one will now give you plus 1 times 10 raised to power minus 1. And 10 raised to power minus 1, of course, this one will go. I'll have 1 times 1 over 10, which will give you 1 over 10. That's what we have initially. So what does that mean? Is that after the decimal point, we are going to put our index in negative now. Okay, so it will be negative index, which starts from -1, -2, -3, -4 till we exhaust the numbers after the decimal point. So what am I trying to say? If I have 0.001, so when I have gotten my 0.1, this one is going to give me what? -1, -2, -3. So that's how we expand numbers that are fractional. Okay, what I mean by numbers are fractional, numbers that have decimal points. So let us come back here and finish what we have here. So when I index this number, let me rewrite it first. So when I index, I will start from this one here as our 0, 1, 2, 3. Then I will move down to this one as -1, -2. Okay, so this 0, 1, 2, 3. After the decimal point, I will now have -1, -2. So that will give us 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0 plus 0 times 2 raised to power -1 plus 1 times 2 raised to power -2. Okay, remember what I told you? Whenever you are using 0 to multiply, you can simply cancel those ones out. So these ones will be out, and this one will also be out. So whatever we have left is what we are going to simplify. So simplifying this one, it will give us 1 times 8 plus, this one is gone. So we have this as 1 times 2 plus, this one will give us 1 times 1 plus, this one will give us 1 times 1 over 2 raised to power 2 raised to power 2. So that's what we are going to have in this, just like what we have here. Okay, because that negative there means is a fractional. Okay, we call it fractional index, which we are going to discuss in indices. So this will give you 8 plus, this one will give you 2 plus, this one will give you 1 plus, this one will give you 1 over 4. That is because 2 raised to power 2 is 4. 1 over 4 times 1 will give you 1 over 4. So you can have your answer as 11 plus 1 over 4. And 11 plus 1 over 4 will give you 11 1 over 4, or you have it as 41 over 4. Whichever way you want to express your number, you can express it. Okay, you can equally express it as a decimal, which is 11.25. So you can also decide to put your base 10. You can also decide not to put your base 10. Remember, base 10 is the only number base that you can write without the base. Okay. Other ones, you must indicate the base. So we are going to solve the second example on fractional numbers that are in base 2 to base 10. Example 2, let's have 1001.111 base 2. Okay, so let us have a problem like this. So the first thing I will do is to rewrite my numbers and index it. Okay, so 0, 1, 2, 3. Here will give me -1, -2, -3. Then we expand in that base. So that will give me 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power -1 plus 1 times 2 raised to power -2 plus 1 times 2 raised to power -3. Okay, so like I said, now there's something I want to point out. I don't say it in the earlier examples. Please, some students are fond of making this mistake. Instead of writing 2, they will go and write 1 times 2 all raised to power 2. Please, this is wrong. Okay, this is wrong. It might not affect in base 2 because base 2s are numbers in zeros and 1. But immediately you move to other base and you try it there, is really going to affect your answer. So please, this one is what we do. This one is not what we do. The bracket, the 2 is on the base. The index is on the base, not on the bracket. They are not the same. Okay, they are not the same. Please take note of that. So let us continue. So that one will give us 1 times 1 because anything raised to power 0 will give you 1. Then this will give you 1 times 1 over 2 raised to power 1. This will give you 1 times 1 over 2 raised to power 2. And the last one there will give you 1 times 1 over 3 or over 2 raised to power 3. So when you simplify the bracket now, you have 8 here. The second one will give me 1. This one will give me 1 over 2. This one will give me 1 over 4. And that one will give me 1 over 8. So when you add all this, when you add this one together, you are going to have 9 plus. You can use your calculator to solve, or you can find the LCM and solve. We have done a class on this when we did addition and subtraction of fractions. So when you do this, you are going to have 7 over 8. So you can have your 9 7 over 8, or you multiply this. This will give you 72 plus 7. That will give you 79 over 8. So whichever method you decide to leave, or whichever way or format you decide to leave your answer, it is very correct. You can as well put it in decimal, 9.875. So you can leave it in this form, you can leave it in this form, you can leave it in this form. So whichever way you choose to leave your answer, it is perfectly correct, unless otherwise stated. Because some examiner will tell you to leave your answer in decimal form, in 2 decimal form, in 1 decimal form. So some examiners will ask you to leave your answer in fraction. So whichever way you are asked to leave your answer, you leave it like that. If you are not given a way to leave your answer, any of these can actually be very okay. Look at this, 31.25 base 10. 31.25 base 10. What are we going to do? Here, it's not like when you are dealing with fractional numbers of base 2 to base 10, where you just put minus index to get your answer. We don't do that here. Here, we separate the numbers. Now, you will agree with me that when you have 2.5, is the same thing with 2 plus 0.5. And when you have 31.25, it will give you 31 plus 0.25. Okay? So if you agree with me on this, we apply that here. Okay? So we apply that here. That is that our 31.25 will give us 31 plus 0.25. Now, when we do this, when we separate the whole number from the fractional part, we convert them using different method. You already know how to convert your whole number to a to base 2. Now we are going to show you how you can convert the fractional part to base 10. Okay? So let us do this one that we are familiar with. So 31 by 2, that will give you 15 remainder 1, sorry. 2 again, that will give you 7 remainder 1. 2 again, that will give you 3 remainder 1. 2 again, that will give you 1 remainder 1. 2 again, that will give you 0 remainder 1. So when you take it from down, you are going to have 1, 1, 1, 1, 1. Okay? So we have taken care of the whole number part. Now, what happens to 0.25? Now, in 0.25, the way to convert it is far different from the way to convert the whole number. So this part of 0.25, we use another technique in converting it to the base 2. Now, what is that technique? Please, I will need you to pay close attention here. 0.25 will keep multiplying by the base times 2, the whole number part of whenever we multiply. Remember, the whole number part whenever we multiply by the base, we are going to attach it here. So this one is going to have point. The whole number part, no matter the number can be 0, the number can be 1, but the number cannot be more than, cannot even be up to the base. So the number is always less than the base, so that we can still maintain a good number in our answer. When you multiply this one by 2, you are going to have 0.50. Now, what is the whole number here? We take it away. When you take it away, you add it here. So when you take this whole number here away, you are going to have 0.50. You multiply it again by 2. 0.50 is the same thing with 0.50. That is because this time around, we have it as 0. Sometimes it might not be 0. So when you multiply this one by 0, you have 1.00. You take it here and put here. When you take this one away, you are going to have 0.00. And 0.00, whenever you multiply by 2, it will give you 00. So that's where we end, whenever we get 00. Otherwise, you continue, probably you stop at 3 decimal places or 4 decimal places. So we now have our what? Our 2. We are going to solve more examples on what we have started already. We have 135.725 in base 10 that we want to convert to base 2. Remember what I said before? you separate the numbers, have your whole number and have your decimal parts. So that will give you 135 plus 0.725. So we are going to convert this one the way we have been converting our numbers to base 2. Then we convert the decimal part the way we also convert the decimal part of numbers that are in base 10 to base 2. So let us do this one quickly. So we are going to have 135 divided by 2. 2 in 13, we have 6, remainder 1. 2 in 15, we have 7, remainder 1. So 2 divide 135 will give us 67, remainder 1. Then we go again by 2, that will give us 3. 2 in 7, we also have 3, remainder 1. So we go again by 2. 2 here will give us 1. 2 here will give us 6, remainder 1. We go again by 2. We'll have 8, remainder 0. We'll go again by 2. 4, remainder 0. 2 again, 2, remainder 0. 2 again, 1, remainder 0. 2 again, of course, we have 1 here, so we have 0, remainder 1. So when you take it from down, we are going to have 1, 0, 0, 0, 0, 1, 1, 1. But remember, we are not done because we still have the decimal parts to deal with. Remember what I said, that when you are taking care of the decimal part, when you have more than 3 or 4 decimals, you can stop there because some numbers might not really terminate. So you need to just stop at a certain point. So let's have our point here. So let's go over to the decimal part and do what we are supposed to do, which is to convert the decimal part also to base 2. That will give us 0.725 times 2. That will give us 0. 5, that's 4 plus 1, 5. 14 plus 1, 15. So I write 1.550. Remember what I said before? Whenever you multiply, you pick the whole number. So I'm going to pick the whole number here. I will have this. So what is going to remain is going to be 0.550. Of course, when you remove the whole number part from this number, you have 0. Or you just have 0.550. They are the same. So when you multiply this one again, also by 2, this one here will give us 0. This one here will give us 0, carry 1. This one here will give us 10 plus 1, 11. So I write 1.1. So I take my 1. So I have what? 1 here. So I have 0.100. So when you multiply this one by 2, you are going to have 0.200. So you pick your 0 also. You can see that if we have 1, we can also pick it. If we have 0, we can also pick it. So you have 0.2, which you can also pick your 0.2. Oh, sorry. Which you can also pick your 0.200 and multiply again by 2. You are going to have 0, 0, 4, and your 0, which you can pick your 0. So we have gotten more than 2 decimal places. We can stop there, okay, and have our base 2. So this is the answer for this particular one. Let's solve more examples and see how if there will be any challenges or if there is anything that we might face other than what we are seeing. So this time around, we have 81.324 base 10 to base 2. So we have our solution. So we convert the 81. Of course, when you separate this number 81.324, that will give you 81 plus 0.324. So let's convert the 81 the way we do our conversion, and we now do our 0.324 the other way of converting the decimal part. Okay, so we have our 81, 2 here, that will give us 40, remainder 1. 2 here, 20 remainder, 0, 2 here, 10 remainder, 0, 2 here, 5 remainder, 0, 2 here, 2 remainder, 1, 2 here, 1 remainder, 0, 2 here, 0 remainder, 1. So when you take it from down, you have 1, 0, 1, 0, 0, 0, 1. Point. We move over to the decimal part. Remember that your decimal part, the same way, you keep multiplying by the base. So we have 0.324 multiplied by 2. That will give us, this and this will give us 8, 4, 6, 0. So this time around, the whole number we have there is 0. So you still pick it and put here and multiply. Of course, when you remove 0 from here, 0 will still be remaining. So you still have your 0.648. You multiply again by 2, 6 remainder 1 plus 1, that's 9, 12. So 2 carry 1, 1. So this time around, we have 1. So you pick it and add up here. So when you remove this one, you have 0.296. So you multiply by 2. That will give you 12 carry 1, 18 plus 1, 19 carry 1. That will give us 5 points. You have 0 there. So you pick your 0. Of course, you still have your 0.592. So you can see that there's no way that that number will terminate if we keep multiplying by 2. So we have gotten our 3 decimal places. You can still go ahead and do the fourth one. 4, 18, take 1, 10 plus 1, 11. So I have 1.1. So I pick my 1. So we will definitely have to stop there, okay? Because you can see that when you remove 1 and you have 0.184 and you continue with that, there is no way that number will terminate when you keep multiplying by 2. So we have gotten 3 to 4 decimal places. You can actually stop at that point. So let us look at 3146 to base 8. Remember, you have to convert this one the normal way you convert. Then you now have to do the multiplication of the decimal part and keep extracting your whole numbers. So let's easily do this one. Solution. You have 31. So you have your 8. 8 in 31. That will give us 3 remainder 7. Okay. So 8 again, we have 0 remainder 3. So when you take it from down, you have 3, 7 points. So we move to the decimal part. The decimal part here is 0.46. That's this. So you keep multiplying by what? 8 and extract your whole number and you put it here. So 8 times 6, that will give us 48. So write 8 and take our 4. 8 times 4, that will give us 32 plus 4, 36. So write 6 and take our 3. 8 times 0, that will give us 0 plus 3, that will give us 3. So we'll take our 3 and put it here. Then when you extract 3, you have 0.68. Then you are multiplying by 8. So 8 times 8 will give us 64. You take 6. 8 times this will give us 48. 48 plus 6, that will give us 54. 48 plus 6, that will give us 54. So write 4 and take our what? 5. So you extract and have your 5. So we have 0.44. You are also multiplying by 8. So 4 times 8, that will give us 32. You write your 2, take 3. 4 times 8 again, you have 32 plus 3, you have 35. So we have 5 here and you have 3. So you extract your 3 and write here. So you keep going like that, but we have gotten up to 3 decimal places, so we can decide to quit at that point. Now, our next example, we are going to look at this form to base 16. Let's see what we are going to have there. So let us look at 78.71 base 10 to numbers in base 16. Remember, numbers in base 16, you have your A, B, C, D, E, and what? F, representing 1 to or 15. So let's start. So we have our 78. When you divide by 16, 16 in 78 will give you 4. You now have 14 remaining, okay? Because 16 times 4 will give you 64. So 64, 78 minus 64 will give you 14. Okay, we know that 14 is not up to 16, so that's what is remaining. Then 16 again in 4, that will give us 0 remainder, 4. But remember that 14 is the same thing with what? Oh, sorry. 14 is the same thing with E. So when you take it from down, you have 4 E point. So we need to go and convert 0.71 to base 16. So 0.71 times 16, what will that give us? That will give us that will give us 11.36. Okay, so you can do the multiplication. So when you multiply this by 16, okay, let's do that here so that you see how we have 11.36. So 71 times 16, that will give us 6 here. 6 times 36 will give us 42. So you write your 2 and take 4. That's 0 plus 4. That will give us 4. So we have this and this. That's 1. This and this will give us 7. This and this will give us 0. So you bring down your numbers. So that will give us 6, 3, 1. You take 1, 1. So, okay, we have our point there. Okay, so that's how we got 11.36. And 11, what do we represent 11 with? Remember, 10 is represented with A, 11 is represented with B. So we are going to write B here. So what is the next thing left? So we have 0.36. So we still need to multiply this by 16. Okay, so if you multiply that by 16, you have this times this 36. The same thing I'm doing here, that's what I'm going to do here. So 6 times 6 will give us 36. I have 6, take 3. 6 times 3 will give us 18 plus 3. That will give us 21. I'll write 1 and take 2. 6 times 0, 0 plus 2, 2. So that will give us 1 times 6 will give us 6. 1 times 3 will give us 3 and 0. So that will give us 6, 7, and 5. So this time around we pick what? 5. So if we pick 5, we have 0.76. You also multiply by what? 16. So whatever you have, you still pick the what? The whole number and leave the decimal. So you can keep doing that and you have your values, maybe one other number or two other numbers. So that is how to convert a decimal number to base 16. Okay, it's very simple. Just take the same process and you will get the same result. Okay, so see you in the next video. And remember to subscribe to our channel and like our video, and do not forget to share our video. Thank you very much. See you in the next class.